Welcome to Henthorn's Performance Electrical 102 class. Today we're going to be talking about the 3 common circuit failures. Shorts to ground, shorts to power, not so common, open circuits. These are the 3 basic electrical system failures that you can run into, and we're going to cover them in as much depth as I can come up with for this video. Thanks for checking in. Let's get after it. We're going to talk about the effects of a short to power on different components in the circuit at different places in the circuit. So we're going to start here. I labeled everything in the major components in a basic circuit with how they tend to be wired in cars currently. Start with, obviously, you have the battery. You're going to pass through a fuse. You're going to have multiple legs to your circuit with multiple controls. You have a relay, a switch, and then your load, then passing to grounds. So let's talk about how a short to power will affect different spots in this circuit. So I colored everything where you should have power and where you should have a ground if your circuit's operating correctly. So if you put a short to power anywhere along this leg here, from where it exits the battery, goes into the relay, you wouldn't notice it as a complaint at all. The only thing that would happen is if it happened after the fuse, from here on, you wouldn't have protection in your circuit at that time. If it happens after the switch part of the relay, if it happened here, this bulb, or whatever your load would be, would never turn off. It wouldn't be controlled at all. If you had a short to power after your load in your relay, here, wherever that power would be coming from, would be shorted directly to ground, causing usually a fuse to pop when this switch was commanded. If you had a short to power directly after your load, it would have the same concern. This is why shorts to powers tend to not happen so much. It's kind of, if you have a short to power, it basically means 2 wires chafed together in the same spot, and it's causing your concern. So they're very rare to happen, and then they do happen, either it's on this end and nobody ever complains about it because nothing bad ever happens, or it's on this end, the ground side of the circuit, and it instantly leads to a fuse being blown. That's shorts to power. Alright, now we're going to move on to shorts to ground. Everything's still labeled on the board. It's still the same basic circuit. Now these issues here are ones that you're going to run into a lot more often, because all this takes is a wire being chafed to the body, which is way more common for them to be chafed to the body than to anything else. So these are going to have a little more outcomes too, a little more noticeable, and happen a lot more often than shorts to power. So we'll start at the top just like we did before. If you have, say, a short to power, short to ground here, this is after your fuse, and it's going to go directly from the battery through the fuse to ground. No load increases the amount of amperage passed through a circuit. So your fuse is going to have an amperage rating. It's going to max that out because there's no load in here, and it's going to cause an open in your fuse. Now say you have a short to ground here. That is going to let your power pass through. It's going to have a pathway to ground all of the time. Just command this relay, a magnet in this relay, which will close the switch, causing this load to be on all of the time, whether this switch is on or not. If you have a short to ground here, it will only have a direct pathway to ground when this switch is on. So this will be something like, anytime I heard that turn this switch on, the fuse pops. So the short to ground is before the load, direct pathway to ground, amperage goes up, fuse pops. If you have, this is where shorts to grounds can be funny, because if you have a short to ground here or here, there's nothing wrong with the circuit. It will never change. Everything will work exactly like it's supposed to, due to the short to ground being after the control and or after the load. The circuit will work exactly as designed, and they'll never complain about anything until that wire breaks and it becomes an open. And that leads us to the next topic. Now, we're going to talk about open circuits. Open circuits is the most common of all wiring concerns. It's the easiest to happen. Wire breaks, door openings, they get corroded, and bad weather or anything like that can cause the wire to get brittle and then snap. An open circuit is the most normal failure point you will see due to poor wire fitment, like poor terminal fitment, broken wires, corroded wires that snap off, anything like that. Fuses, when a fuse blows, it actually causes an open circuit. Bad switches are almost always open circuits. So we'll talk about the effects an open circuit has on the flow of power. So, most common one you'll see, open circuit, and the fuse, usually caused by something else or just a fuse failure in general. An open circuit here will leave you at 12 volts up until that fuse. Same thing directly after that. Open circuit here, leave you at 12 volts up until the open. 0 voltage after, unable to function. If you have an open and a switch, like a bad relay, hit this switch, command your power on, that thing doesn't get good connection, boom. So this whole leg will operate correctly. You'll see 12 volts come down, go into your relay. Just after your relay, you'll see a really low voltage close to 0. It'll be something like 0.1. When this is operating correctly, you'll get 12 volts here. This load here will use that as much as that voltage other than what it needs to pass to ground. And then you'll have 12 volts here. And then you'll be like, well, this is working. I heard a click. But you'll have 0. Flat 0 there. You'll be like, ah, there's an open there. Same thing after here. If you have an open, everything after that point will be 0 volts. And that will cause, weird thing, your 12 volts will pass all the way down to here. This is where things can get even more weird. If you have an open here, you'll be checking all of this, and you'll be like 12.1, 12, and then you'll get 12, which is good. To your bulb, you'll get 12. And then after your bulb, because this circuit can't be completed, you'll have an open circuit voltage of 12 volts. So that's our load side, all the places you have the open, and then the effects on that open on the circuit, and what kind of testing you'll find. We'll get rid of all that. So now, let's say you have an open here. Whether you hit the switch or not, you'll have 12 volts all the way to that open. Now this switch, when it's not being operated, isn't open. So it'll do the same thing. All the way to the switch, you'll have 12 volts. After the switch, 0 volts. Even though it's passing through a load, since it's not working, it's not using the voltage, you will see available voltage there. And that'll be the same. You'll find available voltage on any open after here through the switch. And the switch is on. So if you have an open here, you'll see 12 volts all the way down until that open. And then it'll be 0 after it. So like I said, opens are the most common failures you'll see. They happen in parts, they happen in switches and wires and motors and everything else. But an open circuit is the most common failure, and that there is your normal voltages and how you will see them. That's Henthorn's Performance Electrical 102. Welcome to the second class. Thanks for finishing it out. Now, you see a question at the bottom of the board? Go ahead and throw it out in the comments. Is a relay a switch or a load? Alright.